Hello. Hi, I am Nur Harina binti Muhammad Noor. Together with Nur Farhan binti Azli and Nur Hafizah binti Shahran, we'll do the experiment of M1, which was resistivity measurement of semiconductor by four-probe method. As you guys can see, this was the objective of the M1 experiment. Firstly, is to measure the resistivity of semiconductor materials by using four-point probe. Secondly, to determine the energy band gap of semiconductors. In this experiment, we were using germanium as the sample. Before the experiment started, we need to know what is the four-probe method. In introduction, this method is employed when the film is in the form of a thin wafer such as a thin semiconductor material deposited on a substrate. The sample is millimeter in size and having a thickness W. It consists of four probes arranged linearly in a straight line at equal distance S from each other. A constant current is passed through the two probes and the potential drop V across the middle two probes is measured. An oven is provided with a heater to heat the sample so that the behavior of the sample is studied with increase in this temperature. Let me show you guys the apparatus that we'll be using in this experiment. Firstly, we need germanium as the sample. Secondly, we need the oven, and then a four probe setup, and lastly the thermometer. As you guys can see, this was the probe arrangement in this experiment. This was the procedure for M1 experiment. Firstly, sample of germanium will be put on the base plate of four probe arrangement. Be cautious because germanium crystal is brittle, so that use only minimum pressure required for proper electrical contact. Secondly, outer pair of probes, which was red or black, connected leads to the constant power supply, and inner pair, which was yellow or green, leads to probe voltage terminal. The third step, four probe arrangement placed in the oven and the thermometer is the oven feed to the hole provided. The fourth one, main AC of four probe setup switch on and digital manometer put in the current measuring mode through the selector switch. LED facing a milliammeter would glow in this position, adjust current to 5 milliammeter desired value. Digital manometer put in voltage measuring mode. LED facing millivoltmeter would glow in this position and the meter would read the voltage between the probes. After that, oven power supply connected and oven being switched on. Measurement recorded for increasing temperature by 10 degrees Celsius up to 140 degrees Celsius. Distance between probes and thickness of crystal W were measured. Oven had been switched off and voltage for decreasing temperature were recorded.
In data collection, we used germanium as a sample in this experiment and a constant current which is 5 milliampere. These are the data that we obtained during this experiment. There are two different ways to measure the voltage. First, from the increasing temperature, we take an initial temperature from 50 degrees Celsius until it reaches 140 degrees Celsius. While for decreasing temperature, we apply the same way, but this time we turn off the heat and took the voltage from the highest temperature, which is 140 degrees Celsius, to the lowest 50 degrees Celsius. There are 20 voltage data measured in total varies within the temperature that were obtained in this experiment. The resistivity of the sample can be calculated by the temperature of the oven and the voltage. In this experiment, we took the readings in degrees Celsius. So we have to convert to Kelvin by adding 273 Kelvin for each temperature obtained. From the formula, rho equals to rho initial exponent Eg over 2kT, two graphs were plotted for both increasing and decreasing temperature. Next is the analysis part. For part 1, the temperature increasing, and we have table 3, which we need to calculate ln rho, which is ln times with resistivity. For the voltage and temperature, it is already given in table 2. Then we also have to find 1 over temperature. So from the previous table, we have to draw a graph of ln rho against 1 over temperature to find the gradient and the energy band gap for increasing temperature. This graph is increased linearly. From the graph that we obtained, we find that the gradient is m equals to 4080. And from the gradient value, we can find the energy band gap by using this formula. So, the energy band gap for increasing temperature that we obtain is 0.7031 electron volt. For part 2, the temperature decreasing, we also have to construct a table, which is table 4. And we also have to find the ln rho and find 1 over temperature. The voltage and temperature is already given in table 2. For temperature decreasing, we also have to draw a graph of ln rho against 1 over temperature, and we find that the graph is increased linearly. And when it reaches a certain point, it will bend downwards. From the previous graph, we also have to find the gradient, which is m equals to 3897. And from the value of the gradient, we also can get the energy band gap value. So the energy band gap value for decreasing temperature that we obtain is 0.6716 electron volt. The percentage error for this experiment for the increasing temperature is 3.40%, while for the decreasing temperature is 1.24%, since the theoretical value for the energy band gap of germanium is 0.68 electron volt.
Based on our data, we obtain that the voltage decrease when the temperature increase. This indicates that the resistance of the germanium sample decrease. The band gap energy of the sample decrease when the temperature increase. Less energy is required by the electron from the valence band to jump into the conduction band. Thus, the voltage decrease. This is follow the characteristic of semiconductor. Based on the graph, it is linear at the relative higher temperature but show an exponential relation at the low temperature. Within a set of results, a slightly different was obtained. This is made due to the incuracy of temperature measured by the thermometer. The thermometer was contact with a surrounding air in oven but not only the sample. The difference in specific heat capacity will result in slight difference for the result. This is due to the rate of cooling, heating differ during the two processes, so the system return to the original state of different parts. The percentage error is 3.40% for increasing temperature data and 1.24% for decreasing temperature data. 4-point probe has a better accuracy in determining the resistivity of semiconductor. The energy band gap calculated is 0.7031 electron volt and 0.6716 electron volt.